Welcome back. In this lesson, we're going to continue to investigate solving radical equations. But in this case, we're going to consider something called an extraneous solution. And I know you've heard this term before, but just to review, an extraneous solution to an equation is a solution that doesn't work when checked in the original equation. These are called radical equations when you end up with a quadratic expression and you end up factoring and solving. So again, let's just take a look at what that looks like, what I mean by extraneous solution. So here, the nice thing is the radical is already by itself. So when I go to solve this and I square both sides, well, squaring undoes my square root. But now look at what I've got. I have x plus 5 quantity squared. We didn't run into that at all in the previous notes. But I hope you recall, squaring means something multiplying itself. So what I need you to remember is in all cases like this, I need to remember our foiling process. Okay, so that's going to be the key. The goal in these is remembering our foiling process. X squared plus 5x plus 5x plus 25. And of course, like terms can combine. But now I'm left with something messy that looks like this. I'm left with a quadratic. Now, hopefully you recall, for quadratics, what that means is we need to get everything to one side so we can factor. So remember, that's kind of why I mentioned all of this at the beginning. It's because that's exactly what's actually going to end up happening. So I'm going to subtract x from both sides. I'm going to subtract 7 from both sides. So 10x minus 1x is 9x. 25 minus 7 is 18. So the goal here is to get you to remember that when you go through this entire process, you end up getting something that you can factor. And that means you get your two solutions. So remember, -3 would make that 0, or a -6 would make that 0. So again, kind of a beastly process. However, as long as you remember that process, it should be completely doable because it's all skills that you've previously seen. Now, something you're going to have to remember though. So I'm going to go back and look at this. So remember when I said an extraneous solution is something that doesn't work in the original context of the problem. So if I were to plug in -3 for x, -3 plus 5 gives me a +2. So that turns out just fine when I use the -3. However, I want you to think about when I use that -6. -6 plus 5 is -1, and that is a no-go. You cannot have a radical expression equaling a negative number. So because that would be creating a radical that equals a negative number, it means you can't do it. Okay, you can't use that solution. So in this case, the only solution that you're allowed to use is at -3. All right, so I'm going to show you one more example just to make sure that is hitting home and that you recall what you need to do. So you have a square root that's already by itself, so you can square both sides. That undoes the square root. And then on this side, x minus 3, x minus 3. Again, the big idea is remembering that you can actually FOIL that. So x squared minus 3x minus 3x plus 9. Combine my like terms. X squared minus 6x plus 9. And now I have something here that I need to solve using factoring. Well, the only way that I can factor that is if I get everything to one side. So I'm going to subtract 5x from both sides, add 1 to both sides. Negative 6 minus 5 more is negative 11. 9 plus 1 gives me 10. All right, so factoring this. Well, two things that multiply to 10 and add to negative 11. Well, the only way two things that can multiply to be positive and add to be negative are if both are negative. So we're going to be talking about negative 1 and negative 10. All right, so this means we have a solution of x is 1, because that would make that 0, and x of 10, because that would make that 0. And again, the big picture here is we need to go back and double check. We need to see what would work in the original equation. So in the original equation, if I were to plug in 10, 10 minus 3 is 7, positive number, that's going to end up being just fine. But I want you to know what happens if I try using 1. If I plug in 1, I would have a radical equaling a negative number. And remember, that is not acceptable. You can't have a radical equaling a negative number. So that 1 actually does not work in the original equation. So you have to ignore that expression, you cross it off, and then the only one that truly works is that x that equals 10. All right, so thank you for bearing with me through these notes. Again, I know it's a lot, but you do need to make sure you have all of it written down. And then if you have any questions, please come and see me and ask for some extra help.